Hello, hi, how's it going? This video is going to be a little different from the videos that I normally make. Um, I don't know, the videos I normally make, they're not super coherent, but this is going to be even less coherent and just live session. I got a Sunday afternoon, I wanted to do some coding, we're just going to hang out. When we're first starting to make games and learning how to do that, something we've got to do is just sit down and make 1,000 games. I think John Romero, before he made Wolfenstein and Doom and all of that, I think he made like 80 games or something. There's a lot of benefit to just practicing. So we're going to get up and running with Pygame. This is kind of a Pygame for beginners tutorial. And just get something working. And we're going to sit down until we have like a game running, kind of. So to start with, we open up Visual Studio Code, start a new file, and we'll just save the file wherever we want. I've got a folder here, Game Development Practice, Game 1, that's fine. To save it as a Python file, make it main.py, save that, and now we're good. Run that, and we've got the terminal open. I mean, there are ways to actually open the terminal, but why not? So I've already got Pygame on my system, but if you're starting out and you don't have Pygame yet, the way you do that is you pretty much go pip install Python. Pip stands for Python install package. It's a package manager within Python. Okay. Could I find a version that satisfies the... what am I even thinking? Okay. So this is really raw, isn't it? We're not installing Python. Gosh. We're installing Pygame. Now, it says that we already have Pygame. But if we don't have Pygame, then it will run through a download and install process and get that for us. And one thing I've seen with students, people who are learning Python, is sometimes they'll run pip and it will say, hey, I don't know what pip is, or like unknown command or something. In that case, usually when you install Python, there's an option as one of the click-through screens which says add Python to the path. Now the path is Windows's little registry of like, here are some program names that are being entered, called by name through command prompt or, a VS Code terminal or something. And this is the program location that they link to. If we don't have Python in our path, we can just type in path down the bottom, edit the system environment variables, and then down here, environment variables, and then this one here called path. I think if we double click on that, we should be able to see. Okay, so this one here, Python 3.9 and scripts is where pip is typically. I think if we just copy that and close all of that. Hopefully, I mean, I'm just doing this live. It may work, may not. Okay, cool. So we copy that in, and we can see in the scripts folder we have pip, as well as pip3, pip 3.9. Those are all Python package managers. They'll work just fine. So I don't know if you're running this and you're trying to do a pip install and it's not working, you could try finding the... Okay, so I'll just put this up again. So for me, my pip is within C, uses Andrew, app data, local programs, Python. It's a lot. It's a lot. But there's the path if you want to copy that and use it. Yeah, I don't know why Python installs within like app data instead of C, but anyway. Right, so first thing we'll do is we will import Pygame. And then if we run this, it will say down the bottom, hello from the Pygame community, and there is no error code. Cool. But the thing is, we're going to be calling functions from the Pygame library quite a lot. So what we can do is there is a standard alias for Pygame, just like there's a standard alias for NumPy and pandas and all of that. We're just going to call that PG. So the first thing we do is we call initialization. Now, what that does is Pygame. I should introduce Pygame. Pygame is built on SDL, which stands for Simple Direct Media Layer, and it's it integrates pretty much input and output with the code. So if you can imagine, there's a bunch of modules within Pygame for sound, keyboard, mouse, display, everything. When we call Pygame init, by default, it tries to initialize all of those modules, and it returns an integer which represents the number of modules which were successfully initialized. Okay, so let's get a screen working. Hopefully I'm remembering this correctly. Okay, give this a shot. And yeah, so that popped up for a second and vanished. Awesome. Now, what we want to do is we want to keep it on the screen. So we're going to create a game loop, which will just keep the game running. But if we do nothing in our game loop, then it's going to keep running forever. So the first thing we want to do is get the exit event. Why am I calling? It's PG. Does that work? Let's find out. So a lot of this I'm just working off memory. I'm just going to type it, see if it works. And if it fails, then I've got pygame.org up here, and we can look through the documentation. Okay, we've got it. Now we're going to, yep, perfect. Awesome. Do that again. We've got the screen. We exit the screen. Cool. Okay. So, the screen's blank, so let's fill it with a color. Okay, so there's a bunch of ways we can define a color, but I'm going to define it over here. So let's go So in the brackets here, we have what's called a tuple. Tuple is a read-only data type in Python. It's pretty quick to access. And how this is going to work is each of the numbers is going to represent the red, green, or blue channel for a color. And it will be somewhere between 0 and 255. That's, 8 bits. That's for an unsigned 8-bit integer, that's the maximum we can represent. So we're going to fill this with blue, and if we run it, doesn't work, does it? So the reason that it doesn't work is we need to call the update. Okay, cool. So by default, when we have graphics and we draw them to screen, they get drawn off screen, they're stored in memory. And in order to blit them to the screen that we can physically see, we need to update the display. What else was I going to mention? Well, so just a step back, what this does is it creates a window and it gives us a handle to the surface of the window. Now what a surface is it's an array of pixels. What's a pixel? Well, it's a 32-bit number. So 4 bits for red, 4 bits for blue, 4 bits for, red, green, blue. They get 4 bits each, plus 4 bits for alpha. So you can think of it like just a bunch of numbers filling every pixel of the screen. When we draw, when we fill, what we're doing is we are setting each of those pixels to this value, to just an opaque blue color. Cool. So now another thing we want to do is we want to be able to, let me do this. We want to be able to handle other types of events besides quit. So a cool way to experiment with this is just to print every event. So we run this and we can see down below in the terminal, we have a bunch of kind of default events which are run when everything is created. And then, whoops, okay. Okay, so now the mouse is within the window, and as the mouse moves, there's a mouse motion event, and we can see each of the properties. We have the position of the mouse, its relative movement, so it's movement from the last frame, and also buttons. Now buttons represents the state of which buttons are currently pressed. So I click the left button, we get a mouse down event, and then if I move, we see that the first button there is on, right? So my finger is down on the first button and I'm moving. Now I click the right button and I move. So the left and right are set to 1. When I release those, I get a mouse button up event. Now just note something. When I click and release the left, the way Pygame detects that is this button property, which is currently 1. If I do the right button, that is button 3. I'll try to do the the middle button. That's button number 2. For some reason, the keys on the keyboard have codes within Pygame, but the buttons don't. I don't know why. For instance, let's hit spacebar. We get a key down, text input, and a key up. What do we have? Here it says key is 32, and it's actually not too bad. But then, see, when I hit these other keys, like this is F, I'm hitting F right now. It says key is 102. Let me hit the left arrow key. Key is that number. That's not so helpful. Right arrow key, up, down. So we're not going to get very far if we use integers to represent the keys. This isn't really going to make sense. Like, let me hit escape. Key is 27. Okay, so let's start with that. Let's say I want to set this up so that when I hit the escape key, I also exit. So let's go if event type is equal to just okay. There we go. So it does the stuff that we printed out here was useful, right? So we are checking for key down. Actually, no, let's not. So first of all, we get a key down event, and then we go So see, instead of using integers, we're going to use Pygame's defined macros for the keys. Oh, whoops. Cool. So now let's run this and we hit escape and that's gone. Awesome. So we're getting a little more control. Now, let's say that we want to get a player. We're probably reaching the point where we want to break some of this out and describe it. Okay, so I'm going to say these are my constants. At this step, I'm going to create my objects. Now I'm going to enter my main loop. At this point, I'm going to handle my events. That's fine. So what do? We take any events, any input from the keyboard or mouse. If we have game objects, we're going to update them. Then we're going to draw everything on the screen. And yeah, that's looking fine. Okay. Where are we? So between our constants and creating our objects, we're going to define any classes for like game objects and things. Okay, so we're going to make a class for the player. At the moment, we're going to represent everything with rectangles. Maybe in a later video, we'll make another game with sprites, but rectangles are just fine. Okay, so right, I just put pass there so that it doesn't give error messages. So every class that we want to initialize has what's called an init function. Init stands for initialize, to create, and yes, it does need these two underscores at the front and the back. It's kind of a weird thing. And yes, every function within a class needs to have self as its first parameter. It's a bit of a weird thing, but basically it means that this function is applying to the object and not the class, basically. Right, so when we draw, we want to draw a rectangle. So we'll go Pygame .draw. See, this is the point at which I'm going to have to look at the documentation. So let's pull this up. It's not that this is hard, it's just, what's the point of memorizing this stuff? So we'll go rect. And it doesn't seem to really work there. Here we go. Pygame.draw.rect. Okay. So I was on the right path there. Yeah, this works just fine. All right, so what do we need to do? Well, we need to draw this to a surface, we need to draw it with a color, and we need to draw a rectangle structure. So what I like to do is I like to, when I make a draw function, I take a reference to the surface that I want to draw onto. Color. Okay. So now I'm going to be a little bit naughty here. So I'm going to make a variable called self.color, and I'm going to set that to red. Now, it might be a little strange because for some reason Python lets me have access to this red variable even though it's kind of out of scope. So just to cover myself, I'm going to define that as a global variable and make sure that yes, I have access to this red. Even though I technically don't have to write global, it is easier if we just pick a convention and stick to it. So we're going to draw with self.color, and then we need a rectangle. Now, what a rectangle is, in its simplest form, is a tuple with 4 members, all of those. Now, what we want to do is we want to initialize each of these. So then we think, okay, which of these things do we want to pass in? Well, we probably want to pass in a position to create the player at a certain position, and probably the width and height are not going to change. So if we create another player, it would probably still have the same width and height. So these ones we can hard code in just like we hard coded the color. Cool. Okay, so we've got that. So what can we do at the moment? We can create a player and we can draw them. Now let's go to the stage where we create the objects, and we'll create a player. Now let me see, we need an X and a Y. Let me just, okay, yeah, why not? We'll go 240 480. What am I thinking? I'm just going to create them like halfway. So 320 and 240. Awesome. Right. Now, at the moment, we don't need to update the player. We don't have any update function, but we do need to draw the player. Now, draw order is important. We fill the screen first. That's like the background. And then we draw the player. And we're saying, what surface do we want to draw the player on? We want to draw the player onto our screen. Okay, fingers crossed this works. There it is. And we can see that we've passed everything in correctly, right? Our width is about half of our height. That looks okay. Cool. So, let's change this around a little bit. Just want to show you the way the coordinate system works. So let's say we want to draw a sky and a ground. The sky is going to be blue, the ground is going to be green. I know, I'm very imaginative. So 0, 0 is the top left corner of our screen. If we set the width to 640, that will cover the width of the whole screen. Now let's see. I want the sky to be most of the window. So if I run this now, yeah. Okay, so again, 0, 0 is the top left corner. This would be 640, 0. We go here, down. This would be 0, 300. Okay. Now let's say the ground is down here in this black region. So we want to move the player down so that they are within there. Let's create them at 400, not 4000. Yeah, that's fine. That's fine. We're just chilling out today. Okay. Right. So to draw the ground, we're going to start 300 pixels down, and then if we've got a height of 480, then we can cover another 180 pixels. And it doesn't matter if we go a little bit beyond that, because Pygame will automatically clip that anyway. Cool. So here we are. Now the next thing I want to do is I want to use the keys to move the player around. All right. So in order to move the player, I just need to move their position. So I'll make a function. Now, the change in position will be a tuple. We'll be passing a tuple in. We're going to make two variables, dx, dy, just local variables for this function. And the way I can set those from a tuple is I can write it as if this was a tuple, and that does a kind of copy initialization. So really, the change in position variable looks like this. This is what we'll pass in. For instance, let's say let's say we want to go Pygame key left, so we want to move to the left, so we'll go, whoops, player move, we're going to go -1 and 0. So it's a little hard to see because I've got two sets of brackets here, but the first set of brackets is to call the function, and then inside there I've got a second set of brackets, which is the tuple for x and y change in direction. As a matter of fact, let's create this for the other ones. And as I go through this, I'm going to, on purpose, not do things correctly, because that's how we learn. Okay, so if we are moving right, then that's +1 in the x direction. Okay. Now let's go. Alrighty. So what this is doing is it is adding the change in direction to the variable. Why does that? Yeah, see, it says self is an error, self is not defined, and the reason for that, of course, is for every function in Python within a class, we need to include self-reference. Okay, so if we run this, then we go, oh, that's funny. Ah, no, there we are. Okay, so can you see that? Let me make it a little more pronounced. So what I want to do is I want to hold down the key and move the player. However, here I hold the key and nothing happens. I look at it really closely and it is only moving on key down events, which makes sense because that's what I'm querying here. I'm saying, do we have a key down event? Okay, so the way we can do this is we can, well, what we really want to do is we really want to execute this on every frame that a key is down. So let's go. I think it's something like this. And again, I'll have to check the documentation. So we go, I think it's get keys, that's the one. No, so let's check keys. No. Okay. Right, okay, so it's Pygame key get pressed. So that kind of returns a dictionary. So this dictionary is, let me just double check that. That's giving the state of everything in every frame. Returns a sequence of Boolean variables. Okay, yeah, got it. So what we want to do is we want to say pretty much that. So what this is doing is, I'm just going to change that back to 1. And let me just double check that. Ha! Ah! Oh no. There's no hope. It's moved too far off screen. Okay, but it does work. So, let's do this again. And I'm gonna talk about fixing that in a second. Okay, so now we can move left and right, and oh no, it's doing the opposite. So you probably saw this coming. I waited too long to reveal it, but remember, Pygame uses kind of an reversed coordinate system for the Y. So moving up is actually going in the negative direction, moving down is going in the positive direction. So we run this now, and it's working properly. Left, right, up, down. Perfect. Right, but the reason that I had to change this from 1 down to 0.1 is because of the frame rate of my computer. And if I run this on a different computer, the movement speed will change. So what we want to do is we want to have a way to control the frame rate of the game, basically. So what we'll do is we'll go hopefully that works. That's my motto for this video, is hopefully it works. If it doesn't work, I just look it up in the documentation. So we have this tick function, and what that does is it updates the clock. But we have a optional parameter we can pass in, which is the frame rate that we want to cap the game at. Good. So we're moving slowly again because we are back up to, or back down to, that frame rate. Yeah, I know. I don't type quickly, but there's benefit to that. Gives you time to absorb the information. And this is a little bit slow. Yeah, not that it really matters. Yeah, that's fine. Okay, so the next thing we want to do is we want to move the player, but also limit them. I wonder if that works. Yes, it does. Okay, cool. So what we want to do for the x is we want to go self x plus dx, but then if that is less than 0, then we want to limit it at 0. So we'll take the maximum of 0 and that. Okay. And then if that is more than the screen width, then we want to clamp it at the screen width. So that, minimum of that, and the screen width. Okay, now we're going to do something very similar for the Y. Okay, so I say, what is the minimum I want to set there? Well, the ground stopped at about 300, so we want to say whoops. So we want to say, now what am I doing here? Okay, so if our Y is less than 300, yeah, no, that's fine. That's fine. And then the biggest Y that we want is the screen height. Okay, so let's give this a shot. So we go up, good. Down, oh no. That's not good. We go left, and that works. This is taking time. Grab a coffee if you want. We're off screen. Okay, so the reason for this is the top left is being measured just fine because the X and Y, self.x, self.y, represent the top left corner. Now, this corner represents self.y for the Y variable, and the X variable is X plus width, self.width. Then down here, this is the self.x, but the Y variable is self.y plus self.width. So what do we want to do? Well, we want our maximum X value not to be the screen width. So if I move to the right, my player is moving just off here. I want to actually cap that at screen width minus self.width. And I want to cap this at screen height minus, whoops, self.height. Okay, let's check this. Now we move to the right and we are good. We move down and we are good. Awesome. Okay, cool. So this is all fun, but what if we want to make an obstacle? Well, an obstacle is pretty similar to a player. Let me think. What color do I want to make an obstacle? Well, I don't know. I think this is brown. We'll see. This is probably more of a like a reddy orange, but that's fine. It doesn't matter that much. Well, I mean, the most important thing is that all the objects are different colors so we can tell them apart. So yeah, let's change that. Now we do not need to move the obstacle. It's not going to move right now. We will need to draw it. Yeah, that's fine. Okay. Okay, so I want to make this, let's set it at 500. It doesn't, it's not super important. Okay, cool. So we've got an obstacle that we're drawing. There it is. Ah, that is brown. or at least it looks brown. So the point of an obstacle is that we want to limit the player's movement, right? We want to block the player with this. And furthermore, we've got the issue that the player and the obstacle are sharing a lot of similar code. So I'm going to try to fix that. First thing we want to do is we want to create a kind of like an external function. I call these helper functions. Okay. So what I want to do is I want to take two objects and have a function which returns whether the two objects are overlapping. I'm going to do that by testing the rectangle variables for both of them. But before I do that, I'm going to create a superclass for both of them. What am I going to call this? Whatever. It's a collidable object. Actually, you know what? I'm not going to umming and ahhing. No, that's fine. Yeah, that's fine. And I'm not going to call it a rect, I'm going to call it a bounding box. That's what it is, pretty much. Okay, so now we've got all of this together. We are going to make both of these objects inherit. So the way we inherit in Python is we just put a bracket and the name of the class that we can inherit from. I believe Python does support multiple inheritance, but, well, I'm not sure. I haven't done that. But I'm not going to worry about that. So what I'm doing here is I call the okay, good, just double checking. So I want to instantiate the superclass. And what do I need there? Well, I need X, Y, and then I can hard code these to 40, not 400. Actually, let me just double check that. Or is it that? Fun, fun, fun. So, great. So the geometric data is passed into the superclass, and then we set the color ourselves. Okay. So, for example, when we call the move function, we have access to the self.x variable because that is a property of the superclass, the basic collidable object, which we have. So that's okay, we don't have to do anything crazy there. We can get rid of the draw function because that is already defined in the superclass. So when I go to draw the player, it will call the superclass function draw. And then we can do exactly the same thing down here. Okay, then we don't need to worry about that. And let's see what happens. Cool. So as you can see, we've shortened the code a little bit. And yeah, it works. Side note, the funny thing about game development is, okay, good. I thought I was still printing out events. No, the funny thing about game development is it kind of walks a fine line between what you would call like the academic, perfectly correct answer and just the answer that works. So, for instance, I have fond memories of some very abstracted, object-oriented classes where it was, you know, textbook kind of examples like cat inherits from mammal, inherits from animal, dog inherits from mammal. It's horrible things. Game development code doesn't do that because there is a cost to inheriting. At the moment, we don't worry about that cost because, well, if you're using Python, the performance cost of using Python is much more than the performance costs of inheriting. But we also want to kind of strike a balance between being practical and having good design of our code. Anyway, so now let's look at this overlap function. Now what we want to do is we want to test whether two boxes are on top of each other or colliding with each other. When we think about this, we could look at the corners, but then you've got a bunch of edge cases, like then you have to check, okay, if one box is bigger than the other, then you want to check, you know, if one is inside the other or something. Here's what I'm going to do. First of all, I'm going to grab the parameters of the boxes for each of the objects. There's probably a shortcut for this. It's fine. I mean, a shortcut for changing a bunch of those numbers. Who cares? Okay, so here's what I'm going to do. There are 4 cases where objects are rectangles are definitely not overlapping. Let's look at the left side of object 1. So the left side of object 1 is just given by its coordinate is x1. And what I want to check is the left side further to the right than the right side of object 2? The x-coordinate for the right side of object 2 is given by its x plus its width. Okay, so if the left side of object 1 is too far right of the right side of object 2, then there's no chance that they are colliding with each other. Now let's just keep going with this. So then we check, is the right side of object 1 less than the left side of object 2? If it is, then that's false. Then we say, okay, y1 is the top of, y1 is the top of object 1. And then we look at the bottom of object 2, and if the top is below the bottom of the other object, then they are not colliding, and then we go oops. Okay, now if any of those cases were triggered, then the code would stop immediately and return the value. So if we get to the end of our code and it hasn't returned, well then the 4 cases are ruled out and this must be true. Alright, so let's use this function. So what we could do is we could call a test and a move function for every step of this, but what we could do instead is we could have a variable which tracks this, and then we'll say okay, just thinking here. Actually, let's change that to 3. Make the player a little faster. Okay, cool. So based on the keys which are pressed, the proposed movement changes. Then the way I'm going to do this is first we move the player, and then we check if the player has overlapped. And then if the player has overlapped, then we will move them back. This will just make the opposite movement as before. Okay, so let's try this. And yep, the player moves, and then they it is not letting them run into the box. Now you can see there's a bit of a gap there, and the gap is due to the speed, right? Because it's trying to move the player 4 pixels, but if it moves 4 pixels, it'll collide, so it can go up to like 3 pixels close to the object. There are ways to do that more precisely. There is a bit of a problem though. If I hit 2 keys at the same time, like down and left, it just moves down. So what we can do is instead of this, we can swizzle, which is to alter one component of the list at a time. Not that. And so for instance, when I hit down, it does not reset the horizontal movement to 0. Instead, it just modifies the vertical movement. Okie dokie. All right, by the way, before I was using tuples, here I'm using a list. One of the major differences between a list and a tuple is that a list can be modified, whereas a tuple is like write it once, don't rewrite it. You can't modify a tuple. Okay, so now if I hit up and left at the same time, then we've got, yeah, this is good. This is looking good. Okay, so now what if we want lots of obstacles, not just one? Well, one thing we could do is we could call this, obstacle 1, obstacle 2, obstacle 3, and that's not a lot of fun. It's a lot of typing. And furthermore, if we want to destroy obstacles, well, then it gets more difficult, right? And when we go and do this movement testing, well, then we've got problems. So what am I doing? Okay, so I'm going to create a list, and the way we add objects to a list is we append them. So I call append, create an object, and add it onto the list. I'm going to append a few more. Okay, great. But then down here, well, it doesn't know what obstacles are, right? So what we want to do when we move is we want to test against each of the obstacles in our obstacle list. So what we do is we there we are. Cool. So we use what's called a for each loop. Now what that does is this variable here is the name of the list of objects or things that we want to loop through. And this variable here is a temporary variable, which is just scoped to the loop, which is the name of the object that we're going to use to, as a temporary reference to the current object that we are looking at, right? So it's, and obviously I could even call this whatever I want. I could call it A, that would be the same thing. So what do we want to do? Well, we want to test movement against each of these. So if we have an overlap with a single obstacle, then that is true. We have hit something. And we also want to probably break out of the loop at that point because we're just looking for one hit. The moment we see one hit, we can break out of that loop and continue with the execution. Oh, let's not do that. Okay, so then we test. If we hit anything at all, then reverse. Okay. Yeah, cool. So then what we want to do, now I said that obstacle was scoped to this for loop. However, you'll see the moment I created the for each loop, the obstacle object down here then became okay, because Python lets us get away with things that it probably shouldn't let us get away with. It does not strictly control the scope here. So what we can do is we can go through the loop again. Cool. Okay. And we do need to do that. All right. So again, we do all of our events all together, then we do all of our drawing all together, and we separate those. Cool. So you can see that we have some obstacles there, and we are not able to move into any of them. Okay. So now what I want to do is I want to shoot the obstacles. That sounds like fun. So in order to shoot the obstacles, I will need a bullet. All right. So I've made a bullet object, and I want to make the bullet object a little smaller, and I want to make that a yellow color. Alrighty, so what does a bullet do? Well, let's say we want to shoot the obstacles. So at the moment when we hit maybe spacebar, we'll create a bullet and we'll shoot it to the right. So we'll make a variable called speed. We want the speed to be faster than the player, at least. Okay, so just double checking. Yep, we are good. Okay, so I'm just thinking about this. So what we want to do is we want to track whether the bullet should be destroyed in each frame. So there are two cases when this happens. When the bullet goes off screen, and also when the bullet hits an obstacle, both the bullet and the obstacle should be destroyed. Now, there's a bunch of different ways to do this, but I'm going to leave the creation and destruction up to the main kind of game loop. I'm just going to track in a variable whether this thing should be able to be destroyed. Okay, so we're not going to worry about dx, dy. The y position is not going to change, so we do not have to change that. All we're going to do, yeah, there's no reason that a bullet would ever be to the left of the screen, but let's keep that there just in case. Actually, I changed my mind. Okay. So if, oh yeah, we also don't need screen height anymore. We're just going to be working with screen width. So if our x is larger than that, then Okay, cool. Now again, this is a bit of shared functionality, so we could break this out and put it in the superclass. However, the player also inherits from that superclass, and I mean, it doesn't matter. I don't really feel like... Well, technically the player could be destroyed if the player maybe runs into an obstacle or something, but no, this is fine for this point. So again, especially when we are just starting out, it's good to just make something that works. Okay, so what do we want to do? Yeah, that's fine. Okay, cool. So we've got the bullets drawing and updating, but of course we want to create the bullets. So let's say we want to do this with a spacebar. So we go so we create a bullet. So we append and that's fine. Wait a second. What am I thinking? So it's moving to the right. So we want to put it on the right side of the object plus a little bit, because we don't want the bullet to be created in the player. The player would shoot themselves if we want to set it up later on. So we have a generic bullet that the enemies can shoot back at us. We do not want to be accidentally shooting ourselves every time we hit space. Cool. Okay. So what are we doing? We run the update, and then if our bullet object should be destroyed, then we want to destroy the object. Now, the reason I have written this in separate loops is Python's pretty good. Python can probably actually handle this in one loop. However, when we move on to other programming languages which are a bit more explicit, then we will need to be a bit more careful about this. You can't change the size of a queue while you're looping through the queue. That really messes things up in a lot of languages. So to keep things simple, we're going to do this. Technically, this shouldn't be allowed in other languages as well, but hey, we're going to do it. Okay, so we need to have some sort of destruction function. Where are we? Okay, so we've got an overlap function. So we want to destroy an object, and that belongs to some sort of group. So the way we do this is Python, let me just think, what am I going to say? Okay, so Python is a garbage collected language, which means it automatically checks whether things should be destroyed. Now the test to see whether something should be destroyed is if it exists but there is no reference pointing to it. So for instance, at this point where we appended an obstacle, that obstacle object is created in memory, it exists, and calling the function returns the ID to the object. So what we want to do is we want to take the group, we want to pop, I think. Let me just double check that. Does that work? Yeah, that totally works. Yep, pop. Okay. So typically if we call pop, it will just pop out the last, I think. One of those, the last or the first. Probably the last. But we have I think it's index. Yeah, that's it. Yeah, cool. Okay, so what we do is first of all, we find the position of object within the group. So group is a list, really. And then we pop it out. And then, now that's fine. That is it. That pretty much destroys it. But the last thing we want to do is we also, okay, so we destroy the bullet, which belongs to the bullets group. And then we also want to make sure that this temporary variable bullet is not referring to the object anymore, and that tells the garbage collector to destroy it. So we set that to none, which is equivalent to null. Okay. So let me just check this. As a matter of fact, to really check that this is working, let's go just check if it goes halfway across the screen. Oy, that's not good. Okay, list append takes, oh yeah. Okay, so when I create a bullet, I need to actually call the bullet creation function. Rookie error. Okay, yep, good. So it is destroying the bullets properly. Good. Just going to shoot the bullets from like midway through the player. Okay, maybe the last thing for today's session is let's see if we can destroy the objects. So yeah, that's fine. We're creating bullets. Now we go okay, so bullet update moves the bullet. Then we test against each of the obstacles. So we say if there's an overlap between our bullet object and our obstacle object, then flag both of them for destruction. Then what we want to do is, just checking. Okay, we want to break because we only want to destroy one object at a time. If for some reason we've got obstacles on top of each other, we only want to destroy one obstacle and one bullet. Cool. Okay, so then we need to do exactly the same thing for the obstacles. Fingers crossed. Let's give this a shot. Nice. Cool. Nice. Okay, so what do we have? Let me just recap this. We have the beginnings of a game. We have a player, they can move, etc. They can shoot and destroy things. Cool. That'll probably be it for today. It's been a pretty fun session. Let me know if you enjoyed this. Yeah, just watch this if you're a complete beginner. This is simple stuff. But it is fun. I really enjoy it. I had fun. And let me know if you have any suggestions for like things you would like to see. I will not be providing this code. And the reason for that is I've gone through this pretty thoroughly in real time. And if you're learning, you'll get a lot from, just following along with me, by yourself, typing it down, developing muscle memory, all of that. Anyway, that'll be it for now. Have fun. Bye.